Alright, in this mini lecture, we're going to look at quadratic equations and how they apply to word problems. Alright, let's hop right into it. Our example is the parabolic path of a kicked soccer ball. Um, it states that the height of a kicked soccer ball is measured by the quadratic function f of x equals negative 0.01 x to the second plus 1.18 x plus 2. Now, our variable x represents the ball's horizontal distance in feet. So if we have a person who is kicking the soccer ball, right, we expect the soccer ball to go up and then come back down. Well, that's exactly what our function is telling us, since we have that negative in front of our squared term. That's telling us that it's going to be in the shape of a parabola that is concave down. Now, if we were modeling something else and that value in front of the square term were positive, then we would flip the parabola the other way and it would be concave up like a cereal bowl. So we see it's negative, as it should be, so we know the person will kick the ball and it will go up and then come back down. At the very top, that's known as the vertex. And the vertex is given by an ordered pair, right? X value and a Y value. How do we find that vertex? Well, we can find it using a quick little formula. X equals negative b over 2a. How do we find that Y value? Well, to find that Y value, we're going to use f of negative b over 2a. So once we find that value for x, we're just going to plug it into the quadratic function for x everywhere we see an x and solve for y. So this will give us the vertex. The vertex will give us the y value, which is the maximum height, and the x value. The x value is going to be this distance that it travels to get to that maximum height. That y value is the distance it travels up and the highest point. All right. So let's go ahead and begin. As you saw, we have x equals negative b over 2a. We're going to figure out where those a's and b's come from. So first of all, I'll rewrite the function, and it's f of x equals negative 0.01 x squared plus 1.18 x plus 2. To me, this looks like it's a quadratic function that's in standard form, right? Standard form has all of the terms, the square term, the variable term, and the constant term on one side together, which it does. So it's in standard form. So standard form looks like this, just to point it out. Ax squared plus bx plus c. And to me it does, right? Looks like that a value is sitting right there in front of the x squared. The b value is sitting right there in front of the x, and the c value is right there, the constant. So our a value is negative 0.01. Our b value is 1.18, and our c value is 2. Alright, now we can go ahead and plug it into our formula x equals negative b over 2a. Alright, our b is 1.18, and 2 times our a, which is negative 0.01, and I get a negative of a negative 59, which is 59. So whatever that maximum height is that the ball reaches, so that maximum height will occur 59 feet away from the kicker, right? Because we just found that to be that x value of where the vertex will be. So therefore, it's 59 feet away from the kicker. All right, so now we're going to find that maximum height, how high it went in the air. So we know how far away it went from the kicker horizontally, 59 feet. But we want to see how high it went. So to find that maximum height, then we said that we're going to use f of negative b over 2a, meaning we're going to use f of 59. So everywhere we see an x in our original function, we're going to plug in 59. So again, I'm just going to write my function over. Right, f of 59. So my original function was negative 0.01 x to the second plus 1.18x plus 2. And everywhere I see an x, I'm going to plug in this 59. So we get negative 0.01 times 59 to the second plus 1.18 times 59 plus 2. All right, so now we go ahead and use our calculators and crunch these numbers, and then eventually you'll get 36.81, and again this is in feet. So the maximum height is 36.81 feet, and that's how high it is, how high it goes. Right, so it goes 36.81 feet high in the air vertically as it travels horizontally 59 feet. Alright, so we can label our vertex then. We said it was an XY ordered pair. Well, our X was 59 and our height was 36.81. So this is our vertex. We'll come back and use that later on when it's time to graph. So make sure we have that handy. Alright, we move on to part B. Part B says how far will the ball go downfield and hit the ground. So we've just shown already when that person again kicks the ball, we've shown this maximum height, but eventually it has to come back down. So we've shown this distance right here, and we've shown how high it goes as well vertically. So we've shown the vertex, but eventually it's going to come back down and then hit the ground. Right? So that's what B is asking. B is saying how far will the ball go downfield? And we say downfield, we mean all the way down after he kicks it and hit the ground. So basically this hitting the ground right there, if we say that the ground is like the x-axis, the ground can be like the x-axis for us if we have a coordinate system, then that ground is going to be our x-intercept, where it touches the ground. That's our x-intercept. All right. So to find the x-intercepts, we always sub in for y, the opposite letter, and sub in a 0. Okay. So again, go back to our original function. F of x equals negative 0.01 x squared plus 1.18 x plus 2. Alright, I'm going to substitute in 0 for y. Well, you and I know that f of x really means y, right? So 0 equals negative 0.01 x squared plus 1.18 x plus 2. Alright, so once it looks like this, the only variables are x's, and in a quadratic equation, when I try to solve for x, I can try it multiple ways. First, I can try to factor, but the numbers are kind of funny with the decimals and everything, so I'm not going to try to factor this. I'm just going to go ahead and use the quadratic formula. Remember that? The quadratic formula can help us solve for x. So we're going to solve for x using that quadratic formula. Remember, it was x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, So now we just plug in. Remember our A, B, and our C that we identified earlier? Take a look up in the beginning of the lecture. We identified A, B, and C. So now all we need to do is just go ahead and plug in for A, B, and C into the quadratic formula. So negative 1.18 plus or minus the square root of negative 1.18 squared minus 4 times our A was negative 0.01 times our C, which was 2. And then that's all over 2 times A. A again is negative 0.01. Remember, we identified our A, B, and C earlier. They haven't changed. And now it's a matter of going ahead and crunching the numbers. Usually I would do everything underneath the square root symbol. I would do it piece by piece instead of trying to punch everything in the calculator. So in doing it piece by piece, go ahead and write stuff down. And then eventually we go ahead and get 1.4724 under the radical. And that's all over negative 0.02. That 2 times negative 0.01 gets us negative 0.02. All right, so now it looks as though I need to go ahead and split this up because we have that plus minus sitting right here, right? So I'm going to say x equals negative 1.18 plus the square root of 1.4724 divided by negative 0.02, and x equals negative 1.18 minus the square root of 1.4724, all divided by negative 0.02. In doing that, I go ahead and use a calculator and take the square root of 1.724, add it to the negative 1.18, and then divide it by negative 0.02, and I'll get negative 1.7. On this side, I'll do the same thing, but I'll have I'll be subtracting whatever the square root of 1.4724 is, and then dividing by negative 0.02, and I get x is about 119.7. All right, so I'm going to go ahead and reject this negative value because that's giving me a negative distance. So my distance will be 119.7 feet away. So this lands 119.7 feet away from where the person first kicked the soccer ball. So 119.7 feet downfield. All right, and then my last part is an important part as well. It said to graph. It said to graph the function. So in graphing the function, I already have the vertex, right? If you remember the vertex, that was 59 and 36.81. I'm sorry, 36.81. Right, and an order pair is an x value and a y value. We know that. And I believe, what can we do now? We can go ahead and find the y-intercept because we have an x-intercept. So we have an x-intercept of 119.7. So that's where it touches or crosses the x-axis. So that's another point. So let's find the y-intercept. So how do we find the y-intercept? Well, earlier to find the x-intercept, we set y equal to 0. To find the y-intercept, we set all the x's equal to 0, however many x's we have in our original function. So y is equal to negative 0.01, and instead of x to the second, it'll be 0 to the second. All right? So we're just plugging back into the original function for x, 0 in for x. And plus 1.18, instead of 1.18x, it's 1.18 times 0, and then we bring the plus 2 along. Well, in doing all this math, 0 squared is 0 times negative 0.01 is 0, 1.18 times 0 is 0, so only thing left is 2. All right, so we have these pieces of information: the vertex, the X-intercept, and the Y-intercept. So from that, we can go ahead and graph. I can make a rough sketch, and that's what I'll do. So I'll just make the x-axis start right here with tens, 50, 60, and maybe 120 out here. The y-axis, I'll start with 5 here, up to 35 and 40 here. And this is just a rough sketch. I can go ahead and use some technology later on if I wanted to, maybe desmos.com, and type this thing in and have it pop it out for me, but I just wanted to do it on my own. So the y-intercept is y equals 2, so I'm thinking 2 is about here somewhere. The vertex was 59, the x was 59, right? So 59 is about right here somewhere, right in front of 60. And then the y value for the vertex was about 36, which is right here somewhere, right? So that's the vertex. And then that X-intercept was 119.7, so that's practically almost near the 120. So it looks something like this. It's a parabola, it's the vertex, and then it comes back down like that. So that's the shape or trajectory of the soccer ball that is kicked. So that was solving a word problem that had a quadratic equation or a quadratic function within it. All right, I hope that helped you. If you did, please hit the like button. Feel free to share with anyone else who may need it, and don't forget to subscribe. Comment if you choose, and email me if you would like to see any other videos or any other topics that may have you stumped just a bit for a few moments.